He hacked. What kind of profile picture?
That's, I don't know. I said, give me the weirdest Pokemon shape or figure, whatever they're called. And that's what came up. And then I got to figure out who are the Pokemon nerds. I mean, people that like Pokemon in my class.
Juicy.
All right. On the worksheet, any questions?
No.
Any questions? Okay, these are all wrong. These are literally all wrong.
Which one's right? None.
These are literally all wrong.
I didn't know the line.
All right. Hey, we are 8.5, so we're not really in the middle. We're kind of on the other side of the middle, but we're still close to the middle. Do not sit here every day clueless and let it stay that way. Now, certainly I can teach something you could be confused, right? I try to walk into your classroom at least once, every student advisement. I have plenty of you that come, run over here, Mr. C, how do you do this, right? But if you sit there and do nothing, and you accept the fact that you don't know what you're doing, it's no wonder why you get to test day, you're like, I got another F, right? You have a problem. Fix your problem, right? You don't have a single answer here. Every one of those is wrong. Okay? So I'm not going to pick on him, but there's other people as well too. I know it happens because every day I see on your paper written IDK, which infuriates all your teachers, by the way. Okay? IDK is never response ever allowed in a school. First off, you don't write IDK, you write I don't know in full words, right? Secondly, if you don't know, how come I didn't see you during student advisement? Why didn't you come to me and say, Mr. C, I don't get this, right? Start being better students, right? If for those that apply to it, I got plenty of students here, so that certainly doesn't apply to you. All right, no questions on the thing. Kai typically gets things. Why did you put the word vertical? What does that have to do with anything? Yeah, but what does horizontal and vertical even mean?
You said that yesterday. I thought we had to do that on me. I'm sorry.
Yeah, but none of the only one that is vertical, the ones that are vertical, is only one that's vertical and one that's horizontal. And the last thing we wrote was, if it's a horizontal line, no matter what kind of horizontal line the slope is, and if the vertical line, the slope is not zero, undefined, right? All right, you're going to tell me if he's right or wrong. All right, I don't have the answers in front of me. Let's see. Number one, we're claiming that the answer is 1/7. Okay. All right, the second thing is, okay, there's answers there. I gave you 2 points. How did you find an answer? Oh, okay, I can live with that. All right, I was expecting to see the graph next to it. All right, so now I got to pull up the answer sheet. I was hoping that someone had done it perfectly and I could just.
Why didn't you do that?
Because you're way in the back of the classroom.
And you're always right. Sometimes.
Landon.
I said sometimes.
Glass houses, my friend. Do you know what that means?
You should look in the mirror.
No. Glass houses? Anybody?
No.
What's the metaphor?
Nope. I have no.
Those who live in glass houses should not throw rocks. When you claim the other person is wrong and you live in a glass house, do you get it now? Glass house?
No, I still don't.
Well, let's say that I always lie, right? And all of a sudden I hear someone lie. I'm saying, you big liar, right? I got to get my house a little bit in order before I start criticizing some other people, right? If I'm the big liar, I shouldn't be criticizing other people for lying because I'm not doing the right thing. So that's the metaphor is those who live in glass houses should not throw stones because you live in a glass house. Somebody throws a stone back at you, your house is going to fall down. If you aren't getting it right, why are you criticizing other people? That's the metaphor. All right. All right. Sorry for the delay. I didn't have this ready because I thought someone would have the right answers. Here we go. Let's grade this. Numero uno. Come on, program, open up. How about -2/15?
I was off by 1.
Number 2, 1/9. Number 3, -7/6. Now, if you have 7/6, that is the same as -7/6. The book will always put the negative in the middle anyway. Number 4 is 10/3. Number 5 is -1. Number 6 is 5/12. Number 7 is 1. Anybody put 1/1? That's the same answer, right? 2/1 is wrong. 2/2 is 1. Okay. Number 8 is -1. Number 9 is -1/2. The mistakes that are generally made for slope is you'll get the right numbers. They may be flip-flopped. Instead of -1/2, you may have -2/1. Or you drop a negative. Somehow you forgot that you went down, but you put that as a +1. Or you went left and you thought that was a positive instead of a negative. Number 10 is a vertical line, so it's undefined. Number 11 is 2. Number 12 is 1/2. Number 13 is 4/5. And number 14 is 0. Dropping negative is a very common mistake when you first do slopes. Okay. Once again, these are not going to be pretty graphs today. Collect quickly and quietly. Pass up. Today are not going to be pretty graphs. They are going to be ugly, ugly, ugly graphs. So for those of you that aren't or have not been good at graphing in the past, and by graphing I mean word problems, you definitely need to pay attention. All right. We're going to do 2 chapter reviews for chapter 8 because it's a challenging chapter, and then we'll move on to chapter 9. All right. Now, since this class has a habit of not paying attention, notice the homework says class exercises 1 through 3, and then problems. If there's problems there, yeah, they're all work problems. So these are 7 total problems. Every one of them will require a graph. Every one of them. And these graphs will not be the nice, pretty ones that you did last night for homework. The numbers will be, well, it's real world problems. So the numbers are going to be ugly. And by that, I mean like 33.7 or 450 that you'll have to graph. So today, primarily, I'm going to talk about how do you graph when the graph is ugly. And I'll define what that means more mathematically than using adjectives. Unfortunately for you guys, we're only going to do 2 examples. There's only 2 examples that we will do. I would like to do more, but it takes a while to do all these. So I'm only going to show you 2 examples. The 2 that I show you will be very similar to all the problems you have tonight for homework. Okay? They will all wind up to be these really ugly graphs. I've also already made the graphs for you, if you notice on your papers. The difference tonight, you got to make the whole darn graph yourself. You have to pick the right numbers. And that's generally why it's challenging. All right, we okay to get started? All right, here we go. So there are word problems. It says we're going to do word problems where there's graphs involved. Here's the big picture. Tonight, you're going to make a graph. You're going to graph, and guess what you're going to calculate? You're going to calculate the slope, and you're done. The slope will be the answer to all the questions. So just hang up. You will graph, and it'll be an ugly graph. You will calculate the slope, and the slope will be your answer. Because it's challenging. Yesterday was a silly monkey. Today you got to be a smart monkey to get these done. All right. Recall from yesterday's class. The topic was slope. We defined slope as the steepness of a line. The more mathematical definition was a number that represents how steep a line is. If the number is positive, show me with your arm which way does the line go. If the line is negative, which way does the line go? Right? If the line is 0, has a slope of 0, and if it's undefined, all right, you got the basics. As the number increases, either negative or positive, the line gets steeper, 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 positive. As negative, it gets steeper, 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 steeper in the opposite direction. Okay? As it gets magnitude-wise, magnitude means the number, not whether positive or negative. As that gets bigger, then the line gets steeper. Further, we define the actual calculation of slope as the change in y over change in x. And I said no one ever remembers that. Everyone else remembers.
Rise over run.
That's what you have to remember for all slope. Eventually, we will get a formula next year to calculate slope. You won't have to graph anything next year. You will do a calculation of slope. But we're not there yet. Okay. All right. So the word problems come in 2 flavors. We're only doing 2 of them. The first one is there's no equation involved. In other words, they're just going to give you a scenario. You graph the scenario, Jenna. Then you're going to graph the scenario. It's going to make a line, and then you're going to find the slope of the line. From last night's homework, after you get a line, how do you find the slope? What did you do last night? Yeah, but before that, I gave you a line that said calculate the slope. What was the first thing you did? Anybody remember? Say it again, Preston. You have to pick 2 points on the graph. And it can't be just any 2 points. They must be, somebody sent me an email last night.
Where it's like this.
Lattice points. Okay? So they, Winter. Winter sent me an email saying, wait, what do I do? I said, pick 2 lattice points. So it can't be just any 2 points. It's got to be 2 lattice points. Okay? So this is going to be a scenario where they just tell me something. Somehow I'm going to get some information out of that. I'm going to somehow make a line out of it on a graph. And then I'm going to pick 2 points. And I'm going to calculate the slope. Slope is always rise over run. So yes, we'll be counting squares. But we will have, Lane, we will have one problem. And the problem is the graph will be ugly. In other words, when you look at the x and the y axis, it might not go by 1s. It could go by 25s. Could go by 110. Okay, it could go by 70s. Right? So in fact, you're not going to be counting squares potentially tonight. You're going to be counting the distance between 2 points, vertically or horizontally. By that I mean, if you go from 70 to 100, that's actually how far? If you go from 70 to 100, that's how far?
30.
That's 30, even though it only may be 1 square. The squares go by 30. Yeah, it's only 1 square, but the value is really 30. Does everybody understand what I'm saying? You can kind of look at the example on example number 2 here and see that the squares on the vertical axis actually go by 5. So every vertical square is, so when you're counting up for your rise or down, you actually don't go 1, 2, 3, you actually go 5, 10, 15, 20. To further confuse you, look at the y or the x-axis. The x-axis goes by, okay, welcome to the club. You're the big boy, big girl club, math club, is that you got to be able to look at a graph and keep that straight in your mind. Oh, wait, the verticals are going by 5, the horizontals are going by 1. You're still going to count squares, but each square may represent 1, or in this case, it may represent 5. And yes, you can have different scales for both the x-axis and the y-axis. You may not have ever seen that before, now you are. Okay, so this is going to be 1. Now, for those of you that like steps, write it down somewhere. For the ones that have no equations, like it doesn't say for the instructions, write the equation, graph, tell me the slope of the line. You're going to read the problem. You're going to graph it. You're going to calculate the slope. When you calculate the slope will be your answers for all of these questions. Okay? Is that always the case for any math problem? No. But for these questions specifically, the slope represents the answer. Brecton said in order to calculate the slope, we need at least 2 points. Well, actually, only 2 points. Okay? It doesn't matter which 2 points, but they must be lattice points. Okay, for those that wanted to write it down, you're good. We'll have a different set of steps for the ones that say write an equation. All right, 2 examples, right? It's going to be not a quick class, but it's just 2 examples. And I said these 2 examples, could you just stop? Just stop, whatever you're doing, and pay attention. Okay. So 2 problems. The first one without equation, the second one with equation. All right, so it says the temperature at 8 a.m. immediately red flags go up in your head. Why? Jaden? It's time. What's the problem with time?
Everything.
It's like 6. It's calculated into
You got seconds that are calculated by. You got minutes that are calculated by. You got hours that are calculated by. 24. You got years that are counted by. 360. They're different units all over the place. Hey, there's a second problem that maybe you didn't realize with time. Why is that a problem?
because it kind of splits right in the middle of there. Well,
Think about it. If we had to graph something, right? And the horizontal axis represents t for time. Well, what's the first number here? 1, 2, 3, 4, 5, 6, 7, 8. What's the next number?
10.
9, 10, 11. What's the next number? 1.
oh yeah.
8, 9, 10. Oh, I forgot one more tick mark. 9, 10, 11, 12. Then it goes to 1. There are no number lines that do that. You don't have a number line that goes to 12 and then goes back to 0. So how in the world do you graph time?
You say 24 and you do military.
Then you get to 24, you get the same problem. It's back to 0. Right? Does anybody know how we graph
2
time?
days. Like days.
Then you get to 365, then it goes back to 0.
Years. Years.
We could do that.
Yeah.
8 a.m. in years.
But we're not going to do that.
Hard graph at 8
Do you actually
a.m. in
know?
years.
Okay.
Stop. Listen, this is a big point.
Like continue doing it as normal, but then you divide that number.
Sounds way too complicated. Last guess, and I'll tell you.
You just keep going. Because like
You can't. It goes back to 0.
No. You keep going after 0 and count because sometimes it'll be like in 72 hours. You just keep going.
Just do it in decades.
You're close. You're close.
Wait, can you like do it like this one and have like one side be AM and the other side be PM?
No. All right. I'm going to give you the answer. We're through. Jaden is on the right track, not the right answer. All right. This is done in science class. This is done in science class, and it's also done in math class. The issue is time is all jacked up. 2 things. One, you got to pick 1 unit and stick to it. You want to do it in seconds, you do it in seconds. If you want to do it in days, you do it in days. If you want to do it in years, everything has to be in the same units. Secondly, we actually ignore all of this. Okay, here's how, you guys got to pay attention. Big point here. We're going to ignore all time, and we're going to have a start time, and we're going to have a finish. The start time will always get the same number. Guess what the start time will always get? It's a graph. So guess what the start time will always get? 0. So when you have a scenario, you got to graph it. And in all its time, we're not going to use 8 ever. We're going to use 0. You get to pick the starting time. And your starting time doesn't necessarily match back to the other person, but you got to pick a starting time. You're going to read the problem. There'll be a logical starting time. So we're going to pick a starting time. We're going to have start, and the start time is going to be 0. Start time is actually going to refer to a real time. Give me a real time, somebody.
7 a.m.
So if 8 a.m. is you've probably heard this time before, the 0 hour, right? That's literally what it means. Then when is 12 a.m.? Or I'm sorry, when is 11 a.m.?
3 hours later.
So it would be at 3. So 11 a.m. is not 11, it's actually 3 on our graph. Where is 7 p.m.? On our graph. Where is 7 p.m.?
8.
9.
Well, how many hours till noon?
3.
Oh, no. So
4.
it's,
How many
it's 11.
hours? If 8 a.m. is the
Four.
start,
It's 11. It's 11.
so 4 would be noon. And then how many hours between 12 and 7?
7.
So what number is actually 7 p.m.?
7.
11.
You said that 12 to 7 was 7, and 7 plus 4 is 11. So it turns out that 11 on our graph is 7 p.m. Now we got to stop. I guarantee you half the kids are like, okay, yeah, got it, makes sense. And the other half are, ow, ow. So for the people that were just playing whatever that game is called, you need to stop and you need to tell me, do you got this or not? Jenna, do you got this or not? Okay, Jenna, give me a starting time. Let's see if you got it. Any number's fine. Any time is fine. Sorry. Give me a starting time. Which is it?
He said
6 a.m. or p.m.? She says 6 a.m. is the starting time. Jenna, where does 11 a.m. go on your number line? So the number line would go like this, and you'd have 1, 2, 3, 4. So where is 11 a.m. on your number line? If 0 hour is 6 a.m. I already gave you it. It is 5. Why? Because 5 hours after 6 a.m. is 11 a.m. Okay, I put the 5 on the top. It should be on the bottom. Who's lost? Okay, Angie, pick a starting time. What? So she picked 5 p.m. No, none of these problems have military time, so I'm going to give it to you in civilian time. So she picked 5 p.m. Hey, when's midnight? On your number line. 5 p.m. is 0. Like literally, it's 0 on your number line. Where's midnight? Let her. Okay, the next tick mark technically is 1, right? Well, 1 hour past 5 p.m. is 6 p.m. Where's midnight? What number would I write for midnight? Okay, 7 hours after this. So in other words, 1, 2, 3, 4, 5, 6, 7. This is actually not 7 on our graph. It is actually 12 a.m. Okay. Yes? Okay. Question. You can. So for instance, if that's the starting time, where's 4 p.m.? -1.
Or
Or
positive a lot.
positive a lot, you got to do some thinking.
23. Positive 23.
You'd have to do that was pretty easy for there. So that would be what, 4 p.m. right? If you went to 23, because 24 hours in a day, right? So 1 hour less than back to 5 p.m. All right. All of that was just to do this one problem because it involves time. Oh, by the way, there's another oops. What else does it involve?
Degrees.
What's the problem with degrees?
They're so hard.
Hey,
It depends on what, like, if it's Celsius.
and the reason why they gave it to you in Celsius because life is nice, because 0 degrees is actually 0 degrees. As soon as you get to negative, your life is good, right? So generally speaking, you see a math problem that involves temperature, it will be in Celsius. Fahrenheit gives us problems because 0 doesn't mean what you think it means.
32.
Right. All right. So now we can try this problem. All that. Hey, I was not joking about that. Right. The temperature at 8 a.m. is 3 C. At 10 a.m., it was 7 C. If the temperature climbed at a constant rate from 6 a.m. to 12 noon, what was the temperature at 6 a.m. and what was the temperature at 12 noon. You will solve this by graphing. In fact, we're going to do it right now. All right. Hey, what does constant rate mean?
It goes up by the same thing.
So therefore, what shape does it make? A line. If this was a curve, we could not make this projection. But since it's a line, the slope never changes on the line. All we got to do is worry about our slope. All right, so here's how this one is done. Step number one, we got to graph the information. Notice that every bit of information comes in two. It gives me a time and it gives me a, therefore I have an X and I got a Y. X and Y. Now I've already made the graph for you. Before you tonight for homework make your graph, you got to think this through. If we make time our x-axis, would it be smart to go by ones, or can we need to change it into fives or go by tens? Does this problem right here have a problem that if we graph from 8 a.m. to noon, if we went by ones, we would run into a problem? No, but you've got to ask that question. Because if it was 8 a.m. to 26 days later, 8 a.m., we would have a problem going by ones. We would run out of space. Okay? But in this case, we're only going from 8 a.m. to 4 hours. So all we need is 4 tick marks. We're going by hours. So our X is good. How about our Y? What's the temperature range? So is it okay to go by ones on our Y-axis? It is. So that's what we're going to do. Here's my question. We got to figure out what's the temperature at 6 and 12. It's not listed. But if the rate of change is constant, it makes a line. We just got to follow that slope down until we get to our answer. So let's graph this puppy. Hey, how come I didn't give you the full quadrant or the full coordinate plane?
Because we don't need it.
All the numbers are positive. Now, is it guaranteed? Not really. We might run into some negative numbers, but we're not going to run into negative 400. So all I really need is quadrant 1 and maybe a little bit of space in case it does go negative. But I don't need much. What's the first point up there? What's the first time?
8 a.m.
Upon 0.
Eh.
0.
What's the first time up there?
1.
8.
Eh.
1.
Brecton. It's a 6 a.m. right there.
Oh.
Our first point is going to be 6 a.m. That's going to be our 0 point, but we got a problem with that as being our 0 point. There's no temperature. So I can't use that as my 0. If there was a number attached to it, I could. There's no temperature at 6 a.m., so I can't actually draw where does the dot go? Well, I don't know. That's actually what the question states. So the actual first point that has both the time and temperature is 8 a.m. Okay? So 8 a.m. will be our, well, technically it'll be our second. Oh, by the way, we have to determine time almost always goes x-axis and the other quantity always goes y, because usually this is dependent upon the time. Most things are dependent upon time. So for 6 a.m., I got 6 a.m. and I got a comma. I don't know what the y, but by the way, it's not going to be 6 a.m. It's going to be another number once we determine what our 0 point is. And we said what was going to be our 0 point? 8 a.m. So there's going to be a point right there, right? 0, right? But I don't know where it's going to be because I don't know what the temperature is. What?
3.
Well, eventually we will find out that, no, that's not the right answer, but we will find it out. But we have to draw the line first. Here's my first point. My first point is 8 a.m. and 3. If 0 is your 6 a.m., what would 8 be? If 0 is 6, then 8 would be, who's saying 3?
5.
2, right? Because 8 is 2 after 6. Remember, you establish your 0 point? So the actual point is 2, 3. Graph that. There's your first dot, 2, 3. Big honking dot right there, 2, 3. There's your first point. Jana, your lap does not have the answers. Okay, We good? Do we have another point up there?
Uh-huh.
What's the other point?
6:12.
Okay.
7.
We got 10 a.m. and it's 7, but that's not a point. That would be over here. So what's the relationship between 6 and 10?
4.
4, comma.
7.
Graph that point.
Wait, so we're supposed to figure out.
Hold on. We'll go. We good? Our last point, which we can't graph yet, will be 12. So what's the relationship between 12 and 6?
6.
So it's going to be 6, comma, question mark, right? These two will be the answers that they're looking for. We said it's a straight line, right? So the slope never changes. So the question is, what's the slope? So what's the slope? Okay, we're back to silly monkey. Well, I take my silly monkey, I simply count squares. Am I going by ones or am I going by any other quantity? Going by ones. So it looks like it goes up. It looks like it goes up 4. That's my rise, and the run is
2.
So in other words, reduce, that is,
2.
the slope is 2 over 1. 2 is my rise. 1 is my run. We okay? Well, how is that going to get me to the answer? Watch. That's the slope between any two lattice points, 2 over 1. So let's find the next lattice point. Hey, you see this point? Well, there's got to be another point over here. Let's find it.
But we don't.
From that point, we just apply the slope. The slope is what? So from this point, I'm going to go up
2.
and over. There's a point right here. And that point apparently goes down to what time?
5.
But 5 is actually 5 plus 6, which is, do we need 11 o'clock or no? We need noon. So put one more time. One more time. What was the slope?
2.
Up to.
Okay, here's the problem. We ran out of graph space.
So it's 11.
But we could go up to and over 1, and we'd be right here.
It's 11.
And that would be 6 hours after the starting point. That would make it noon. And what's the temperature?
11.
Does everybody see, even though there's not 11 there, it would be 11?
Yeah.
No way.
So the point at noon would be 6:11. So in other words, what is the temperature at noon? 11 degrees C.
This is.
All right. So there's our first. Did I do that first? I might have done 6 a.m. first. No, I didn't. I did it right. Okay. Well, how do we find the other point?
You go down to. I'll go
We
down
take the slope and just do the opposite of it.
We turn it to
So instead of going up 2, we're going to go, instead of going right 1, we're going to go,
left 1.
so let's do it. So go down 2, and then left 1. Are we at 6 a.m.?
No.
We're at
5
7 a.m.
How?
because 0 plus 1, and if 0 is 6, we're at 7 a.m. So we need to go
Down.
to, and now we are at 0, but what's the temperature?
Negative 1.
What's the, remember the temperature is here.
Negative
3, 2, 1, 0,
Negative 1.
-1. I said we're doing 2 problems. That took us 20 minutes, sorry. 20 minutes to do 1 problem.
It's easy.
This doesn't make sense.
So at noon it's 11, and at 6 a.m. it's -1. Now, tonight for homework, they're like this. All right, so if the people are confused, tell me where you're confused.
Everything.
Oh no, that's not true.
Okay, well, like,
You yourself put your dots right there. You calculate the slope. You told me it was 2 over 1.
yeah. I
It's
get
not
that
everything. So once we have these 2 points, we were trying to find out where noon is. Noon is, it's not 12. Noon is at 6 on our graph for all the stuff we talked about before. So I find 6, 6 is right here. We got to find out where the dot would be. We apply the slope to the previous points, up 2 over 1, up 2 over 1, and we finally arrive at the 6 on our x-axis. How do we find 6 a.m.? We do the opposite slope. The opposite of 2 is -2. The opposite of 1 is -1. So instead of going up 2 over 1, we go down 2 over 1, down 2 over 1, until we get to the 0 hour, which was 6 a.m. Genevieve?
But let's say that like the time didn't go past like 10. Couldn't you still?
It didn't. Okay, so I gave you a graph that was, we needed one extra line.
No, I mean like, what do you have if we had a time that we didn't have to like?
Yeah, so for
we would have
instance,
to substitute it with that.
yeah, let's, for instance, if the question had stayed, what is it, at 11 a.m., we wouldn't have needed to go about that one first time. Remember, 11 a.m. will be 5 hours after the 0 hour. Nate? So are you okay that this point right here is x-axis, 4 hours after the start, 4 plus 6 is 10 a.m. We need to get to noon. Noon is 2 hours after this 4. So we need to do this slope, which was 2 over 1, so up 2 over 1. I'm right here, right? That puts me at 11 a.m. I need to go one more, up 1, 2 over 1. Now I'm at noon. And the y-axis was the temperature. The y would be 1 click above, that's 11 degrees. Yeah. So what? The 11, right? The y-axis is the temperature in degrees, right? Well, see the red dot? Look over to the right. What's the number? Oh, there's no number here, but it would be up 1 click, right?
I forgot that.
Right, yeah.
So for these problems, can you like check to see if you're right? Because I know that for this one you could check. Like, double
Well,
check.
if we wrote an equation for this, we could, right? The next one you'll see, right? This one, since there was no equation involved, it would just plug things into a graph.
Technically, wouldn't it be 5 a.m.?
Which one? We decided that 6 a.m. would be 0.
Yeah, but it's negative.
But remember, that's the x value. X value, 3, 2, 1, 0. We are on the x value right here. This is the x value right here. X is 0. Y is -1, but x is 0. This point is 0, -1. 0 is your x, -1 is your y.
You said the
0 is your time. Y is your -1.
You said the table of pain was hard, but this is harder.
It's not
This one is only hard because it involves
Time. and
Time.
temperature.
temperature part didn't have do much pain here, but the time is very painful. Right?
So how did you get as the 0?
We get to pick. You could have picked this as your 0. If you had picked 8 a.m. as your 0, guess what your x value would be right here? -2. Now, could you have done that? Sure. Because 2 hours earlier from 8 would be 6, right? So if you decide instead, and it was a choice, if you decided that this was 0, you could have, then this number would be -2. It'd still be -2, -1. We'd still got the same answer, right? It's just that where do you determine where your 0 was? It's your choice. Okay? I did. I found it. That was the final answer. That was what we were looking for. Now, I said what I said originally. It would be nice if your first point has an x and a y, but it's not required, right? All right. But what is required is once you set that 0, that you can relate all the other ones, boys. You guys can sit next to each other. All right. So 2 ones. We got about not much time left, so we'll do this one quickly. So the ones that involve the equation, so you still read the problem, but you write an equation now. Make a table of pain, graph. Once again, your slope is going to lead you to your answer. Your slope is going to lead you to the answer. The only nice thing is that the second one is not as difficult as the first one. All right, I will pull this up at the end of class again. All right, a lot of words. Marianne, you know what a calorie is?
Yeah.
It's a unit of
Wait,
what?
pounds.
Food.
It's a unit of energy.
Oh.
Right. Marianne uses 15 calories of energy, it says right there, in stretching before she runs, and 10 calories every minute she runs. Okay. Write an equation that relates the total calories y. Tell me what y is. Total calories is going to be y that she uses when she stretches and goes for an X minute run. It even tells me what would be used for your X. X is going to represent minutes. Graph the equation from the graph, determine how long she has to stretch and run to use up 55 calories of energy. Okay. How many calories does she use stretching?
15.
Okay, that was pretty easy. My graph is already determined. It's got a Y and an X, right? It says total calories will be your Y. It says X will be the minutes that she runs. But there's also this fact that she uses 15 calories. So this has got to be part of the equation. So no matter how many calories you use running, we always have to do what with the 15? Oh no, that's total. We got to add it. So there's your, so if we were to write an equation, well, it'd be the stretching calories, which is always 15. And to that, we need to add the running calories. Well, how many will that be? Always 10? You run a marathon, it's 10?
Yeah.
It's always 25?
No,
But you add
10 every
15
minute.
to it.
Every minute you run.
So then what would I write? 10
10.
times the X, right? The running calories would be 10 times every minute you run. So if total calories is Y, the stretching calories is always, and the running calories is 10X.
Whoa. Too fast. Too fast.
That's what I told you. It's not 25. You can't add 15 and 10X.
You added the first time and then you keep going by
Correct. So all we're doing is adding 15 one time, and then for every minute we add 10 times that minute, however minutes. Okay. Does this look like what we did just a couple days ago?
Yeah.
We just got to graph that. How do we graph it?
Get X whites.
Get Y by.
It's already by itself. Congratulations. Now what?
Do
No, Y by itself. We got to do table of pain. Okay.
Bro.
Remember I said I like it when the X is first. You'll find out why next year. All right. It doesn't have to be first. So now I'm going to erase all this crud right here, and we got to do a table of pain. All right.
No.
Okay. What numbers are we going to pick?
Negative
Well, you can't run -1 minutes.
One, zero.
1, 2, 3, 0, 1, 2, any of those will work. Okay. I'm going to always choose 0 because it makes my life easier. Okay. So here we go. We can do this very quickly in our head. Hey, 0 times 10
0.
plus 15.
15.
1 times 10
10.
plus 15.
25,
2 times 10
20,
plus 15. Okay, that was pretty quick.
Told you it was 25.
What's the problem with these points?
we can.
The X's go by, it looks like the Y's go by in order to fit in the graph. So when tonight you make your graph, you're going to run into this problem. You could have gone by 10s. I just look at these numbers. I'm like, well, let's just go by 5s. So could you plot this if the Y's go by 5 and the X's go by 1s? Like, yeah, we can do that. So here's my graph. I mean, I went all the way up to 70. I don't know how high I got to go. I certainly need to go higher than, what was the number? 55. So maybe at least a 60. Okay. Do we have 3 points to graph?
Yeah.
Heck yeah, graph those 3 points. 1. There's 0, 15. There's 125.
Now this is easy. Now.
I told you that. You didn't listen to me. And there's 235. Okay.
I can give you the.
Yes.
Make
It's
the
not just
one.
supposed to be a bar.
No. Okay. We said in the steps, now we got to calculate the slope. Uh-oh, we got a problem because the Y's go by. So when we count 1 square, we're actually counting by. So what's the slope? Up 1, 2, but that's really 5, 10 over 1. So technically the slope is what? You went up 2 boxes, but that's really 10, and we went over 1. So it's 10 over, stay, we're not done. So the slope was actually 10 over 1. That was pretty easy. Hey, what was the question?
How many groups are mine?
So then you go up.
Look on your graph of where 55 is and draw a horizontal line. Do we have any points there? So we have to apply the slope to the point. What's the slope say to do?
Up to over one.
Over one.
They're
Units.
thinking ahead, right?
Units.
They're thinking of boxes. We're thinking of units. It is 10 units, but that equates to 2 boxes. Who got lost on that? Each box is 5. So if I go up 2 and then over 1, I'm right here. Did I get to my line?
No.
So then I need to go up 2 over.
One.
Am I at my line?
Yeah.
What does it say? How long does it take her to get to 55 calories? And that number is later. All right.
I don't know anymore.
All right, Donovan, what do you think?
I got it pretty well, yeah.
Cool. Sweet. Just be ready for some really ugly graphs for homework.
Okay.
All right, catch you later.
I found this in my desk.
That's a seahorse.
Yeah,
Look
I
at
know.
that.